Right, I think we'll make a start. We'll probably get a few more people logging in as we progress. Uh, but yeah, there's a little bit of sort of intro that we have to go through before we actually get to the into the CAD system. So that's okay. So if I remember rightly, last week we sort of finished the session and we were working through part of this PDF file here. So this Advanced CAD-CAM-3 PDF, sort of, I've designed that so that it covers the first few weeks of work. Certainly, we've been using it in week 1, week 2. We're sort of a little bit behind where we would expect to be normally in week 3, but that's okay. We're going to catch up as we progress through and we get a little bit more proficient at using Creo. So yeah, we're going to be using this Advanced CAD-CAM-3 document again. So I'm just going to get that open in one of my browser tabs. So here it is. And if we quickly scroll through the first section, you can see some of the work that we've been doing. Keep going. And I think we last left the previous week's session. We'd done things about rounds and chamfers and hole features, and we'd done a little bit of work on patterning. I've then, as I tend to do with this document, given you some examples. I still haven't got the attendance code, I'm afraid. I've been directed to IT and I've sent them an inquiry, but they haven't helped me with my problem yet. So, yeah, we'll see if they actually solve the issue that I've got. I believe it's because I'm off site and I haven't got any university provided hardware. So I'm not using a university system. I believe that's the problem. But yeah, I've bumped it to IT and they're looking into it. So as soon as I know anything, I'll let you know. So yeah, back to what we were doing. The general form of this document is I insert these exercise examples for you to hopefully practice your skills that we've kind of covered in the sessions. So these aren't intended to be sort of performed in the actual tutorial itself. They're just sort of focusing on some of the skills that we've covered in each tutorial. So the new piece of work that we're going to tackle in this session starts here. So it's drafts, shells, and ribs. So essentially, there's a little definition that I've written at the top here. So draft angles or adding draft features to your designs tend to have been included in Creo to allow molded parts or parts that are designed to be, let's say, injection molded as an example of a molding technique. So parts that are intended to be molded when they're manufactured, it allows them to be more easily removed from the mold tool itself. So I think what I've also included in this section is some examples of draft angles. So here's a little example. If you were creating a mold such as this to mold something in, when the material that you poured into the mold or injected into the mold solidified, it would be somewhat hard to remove. And that's because these vertical edges remain the same distance apart all the way out of the mouth of the mold. Whereas if you do a redesign on this sort of mold setup and add, let's say, a half a degree angle to the faces, that would be a minimum value. The value for injection molded parts is probably nearer 3 degrees, let's say. Then you can see that if you were to pour some molten material in here and it was to solidify, it would be significantly easier to remove that molten material. And that's because of the friction or the sort of gripping force between these side walls and the direction that you want to remove that part in. There's another little graphic there just kind of illustrating that. That's probably more akin to what you would do in injection molding. Yeah, let me type this in here. Sorry, still no code. I'm afraid. I'll just put that in there for any latecomers that are coming into the session. So, yeah, this is more akin to injection molding. And hopefully, if we have time this session, I want to give you a little bit of an intro to the project that's going to be set. And part of the project work that you're going to be set is related to creating parts that are going to be injection molded. So the sort of skills that we're going to cover in this session and the tools within Creo are quite relevant to that in that respect. So yeah, draft angles are useful to allow you to more easily remove the molded item from a mold when the mold opens. So this is a two-piece mold. It has what's known as a core, which is sort of the male half of the mold, and a cavity, which is sort of the other half of the mold. And when you split the mold, you pull those two pieces of mold apart from each other in a certain direction, opposite directions, obviously, and then the part has to be removed either from the core itself or from the cavity, and adding these angles to any faces sort of aids that removal, if you like. So that's kind of a quick description of why you would want to put draft angle on things. The shell tool within Creo, which is another tool that we're going to learn how to use. So the statement that I've written here is the shell tool allows the creation of thin-walled geometry to be easily created from solid geometry. And if we just flick forward a few images here, you can hopefully see that initially this design was created as a sort of solid block of material here. And then using the shell command, that block is reduced down to a thin wall. So that's kind of what the shell tool allows you to do. And again, quite useful when you're designing molded parts, and specifically injection molded parts for our purposes. And then the last sort of tool that's useful in the design of this sort of type of product or type of manufactured product is a rib feature, which you would tend to add to a design such as this that has a thin wall. So you can see this has a 1.5 millimeter wall thickness. To add strength would be one reason that you would add a rib feature. So you can see a simple sort of strengthening rib has been added there. So we'll learn how to use that tool to add these rib features into the actual design. And there's other types of ribs, so you can see that we've got some sort of cross ribs here that reinforce the design entirely. So those are some tools that are certainly very important when you're designing injection molded parts, but more widely than that, they're important if you're designing any sort of molded part that's intended to be produced using some kind of molding technique. So those tools are useful. If and when we get to the end of that section, which I hope we will sort of within the first hour, maybe a little bit longer, what we're then going to take a look at is the use of parameters and relations within Creo. So I think this was covered in one of the lectures. What are parameters? I think relations were mentioned in there as well, but we're going to actually have a look at their use. So we're going to use this box that we will have just created using these new feature types that I've just talked about. And then we're going to take that box through and we're going to add some relations between some of the measurements within that design. So we're going to add some calculations essentially. So we're going to tell the system, I want these parameters to equal a certain value that I can set at a central location. So yeah, we'll learn about parameters and relations, and specifically how to use them in Creo. And then that should finish this week. So once we've done that, and then you can see this document then leads us into next week. So next week we'll be tackling things such as sweeps and blends. So there's a bit of an intro into that. But let's go back all the way to the top of this section where we should be starting. So here. And initially what we're going to do, we're just going to create a simple extruded block. So hopefully you can see the dimensions there. I would recommend that you get this PDF on your screen so that you can refer to it as well. But essentially, this is 200 millimeters by 130 millimeters by 60 millimeters. So hopefully by this point you should be able to create that as an extruded feature, and you can kind of see where the datum planes are located. They're located right in the center of the rectangular sketch that was created to create this extrude feature. So I'm going to create that. I'm going to pull the reference material across onto my other screen, and we'll keep looking at it momentarily. But we need to get into Creo. We need to set our working directory, which I nearly forgot to do there. So it's always good to try and remember that. Set your working directory first. So I'm going to navigate to where I'm saving all of these tutorials. So I've got a specific 2021 tutorial folder. And then I'm going to tell the system I want to create a new file. The default file types should all be fine here. It should be a part. It should be a solid part. That should be okay. I might give it a specific name. So given the features that we're looking at, draft underscore shell underscore rib or ribs. So yeah, that gives me sort of a reference later on to try and figure out what this part is actually a model of. Then this setting is the one that you want. Now my system defaults to this setting. I realize that some other people's installations maybe don't default to that setting. So I'll leave it on the screen for a while. It's millimeters, newtons and seconds. So it's mmns underscore part solid. So make sure. How do I change the default? That is a very good question. It's been so long since I installed this. Yeah, how do you change the default? I'm not entirely sure. Let me get back to you on it. I will play around with my system. It is one of the downsides to me having installed this system sort of quite a while ago now. So yeah, it's sort of been lost, that knowledge. But I can poke around in here while we're not in a live lesson, and I'll come up with the answer for you. I'll bring it back to next session. So leave it with me is the answer. But that's the one that we're going to use. So we click on OK. We should get dropped into the part modeling interface. We can sort of rotate around and have a little look at what we've got. Again, as I say every session, if you can't see the planes, maybe have a look up here in the datum display filters. And you can see, you can hide various different types of, these are all known as datum features. So the planes themselves are datum features, but there's a datum coordinate system as well that sits in the center there, and you can hide that or make it visible. You can see that popping up. And then later on, when we get a bit more advanced, we'll use datum points and datum axes. But you can simply hide and show everything just by clicking select all at the top. So yeah, that should cover that. So what are we going to do? We're going to create an extrude. So we want to be in the modeling tab or the model tab. Click on extrude. It's then asking us a question, as we sort of covered several times. If you want to know what the question is that it's asking, it's down here on the left. Select a plane or planar surface to create your sketch, basically. So I think I'll pick the top plane because I interpret my reference image here as sitting on the top plane. Yeah, there it is. It says top there, where the sketch is located. So now we're looking at our top plane at sort of 90 degrees to it. We're looking down from above. So I want the rectangle tool, but I want to make sure that the type of rectangle tool that I've selected is the center rectangle, because I want to lock its center point onto the point where the planes cross in the center of the screen there, the origin point of my part. So center rectangle is what I want. The first click is going to drop the center. And when I get near that origin point in the middle of the screen, you can see those two constraints become visible. So they're both in green color when I get near there. Basically what that's saying is if you click here, we will lock this first point to that horizontal plane that you can see there and that vertical plane. So that has the effect of locking it to the origin there, where the two planes cross each other. So click there, drag out. The size and scale of this doesn't matter in this instance because we're going to instantly add dimensions to it. So just click somewhere to drop it, hit the escape key to get out of the rectangle tool. You've created the rectangle, you don't want to create a second one. And then just double click on these dimensions and modify them to what we require them to be. So horizontally it is 200. So just edit that value and press enter. Vertically it's 130. And then we're happy with that sketch. It's been locked in position. It's been dimensioned. It's formed a closed boundary of edges. So you can see it's got that pink shading on mine. So we can click on OK. So we want to OK that sketch and move on to the creation of the extrude itself. So OK the sketch. Now we're defining the extrude, but it's not immediately obvious from my perspective there, from my viewpoint, what is going on. So what I'm going to do is click on the middle button and drag and just maybe zoom out a little bit and zoom back in, just so I'm more aware of what I'm looking at there. So what depth do we want for our extrude? So I'll just check with my reference. We want a depth of 60. So we can just, rather than going up here and entering 60 up there, that's quite a long way for me to bother to move my mouse pointer. Just double click on the value that's indicated over the top of the box there. And then type in the value that you want it to be. So that looks good to me. That looks fine. So I'm going to click on OK. I'm going to OK the extrude feature. So before we were OKing the sketch, now we're OKing the actual extrude feature itself. So OK, so I've got my first feature. That looks good. So onwards, let's have a look at our PDF. Create the extrude using a rectangular sketch. Yep, we've done that. Select the draft tool, click on the references tab, select all the 60mm high faces. So hopefully we can see there. The faces that are getting selected are the ones that run around the outer perimeter of our box. So all the ones that are 60mm high, those are the faces that we're selecting. And then there's a little bit extra here. So once you've selected all those 60mm high faces as draft surfaces, you've got to hold Control down while you're picking them all. Then what you do is in the next box down, which is this box here, when we get to this point, you tell it where the draft hinge is, and that would be the bottom face of our box. So the face that we can't currently see in this screenshot. So with those two things entered, we can then set an angle that we want our draft to be at, essentially. And I think it's going to be 10 degrees. Yes, it is. So we've got the broad outline of what we're doing. Let's actually do it now. So back to our modeling environment. So make sure you've not pre-selected anything. It's a common mistake that maybe you've inadvertently clicked on a face or something, and then you launch your tool, let's say the draft tool, and the draft tool accepts that face as your first input. So make sure you haven't done that. Click in some empty space with your mouse pointer, just so that you deselect any faces on the model that are points or edges that you may have inadvertently selected. Then we're going to select the draft tool. So most of these tools that we're going to use in this session, or all of them in actual fact, are in the engineering sort of subsection of the model menu. So click on draft, and it's waiting for some input. Now at this point, we've sort of been we've not been delving too much into the detail within these features. And when I say delving into the detail, all of these tabs here supply you with further options about the feature that you're going to create. And we've been kind of leaving them shut as a general rule and just clicking on things. But in this instance, it's useful to sort of have a look in them and see what data is in them. So I'm going to click on references, which is the one that's highlighted in that sort of pink. So click on references. And essentially, these are the three inputs that it's going to require from me to create this feature. The first one is called draft surfaces. So if we select that item there, if we just click on it, just to make sure it's that box that is ready for some input from us. And the draft surfaces in this case are going to be all the faces that are 60 millimeters high. So you remember this extrude was a 60 millimeter depth extrude. So, but in order to pick them all, I've got to hold down Control as I click on them. So you can see I've got 2 collected there. They're highlighted in green. I'm rotating round to the back of my part, and then I'm holding Control again. Once I get there, clicking on a further face, and then I can let go of Control momentarily, but then I rotate around again so I can see this one, and then I press Control and click on that face as well. So I've got 4 faces selected there. And if you don't hold Control down, so I'll just temporarily delete them. So now I've got none selected. What it does is it deselects the last one that you clicked on. So this is what happens if you don't hold Control down. You don't collect numerous faces, you just end up collecting a single face. So you can see it keeps deselecting the previous one. So you've got to press Control when you add another face to that entry box there. So we've selected all the faces that we're going to apply the draft to. Now we have to give it a reference as in what is the hinge, because what it's going to do, if we bring our reference image back, you can kind of see visually what it's done there. It has added an angle to a previously perfectly vertical face. And the way it adds that angle, so you can hopefully see the angle, I'll just zoom in a little bit there. So there's the angle indicated of 10 degrees. So one edge of your face remains where it is on the original design, and in this case it's the bottom edge, and the top edge moves outwards to achieve that angle. So that is defined, which edge stays where it is and which edge moves is defined by the face that you pick as your draft hinge. So my draft hinge, so I'm going to click on this box here that says draft hinges, is going to be the bottom face. So if you remember it as the face that you specify as your draft hinge, that defines where the pivot point is. Then I'm going to set an angle. So here's the angle currently, 1 degrees. So I'm going to set that at 10 degrees. Now for my purposes, that's gone in the wrong direction. So what I can do there is I can flip the direction, reverse the pull direction. So up here, there's a reverse option, or that pink arrow there, I can simply click on it like that. So the sense of the draft then gets reversed. So I want to add it in that direction, like that. So what I'm considering the top of my box, I want it to grow in size, and then what I'm considering the bottom of my box, where the draft hinge is, I want it to remain the same size as I designed it. So that should be everything. The pull direction's been automatically generated, and it gets automatically generated using the draft hinge as a reference. So that pull direction is the direction of the mold splitting. So if the mold is a 2-piece mold, it will split into 2 halves, and it will be in the direction of this arrow and the other direction as well. So I'm going to click on OK, and I've added my draft feature. So there's the draft feature added. It's been added to all 4 of those faces that I selected. So we've added it in. So let's move on. Let's add some round features. So we've encountered the round tool before. The round tool should be familiar to us. And you can see, hopefully, what we're doing with the round tool. So use the round tool to add a 25mm radius to the upright edges. So you can see on each one of the 4 corners, the vertical edges that now have an angle on them, angled outwards, add a round feature to all of them. And then after you've done that, and that has been created, add a second round feature to the lower face and set that one at 15 radius. So we should be able to do that relatively easily. So I'm sure I said when we were using the round tool The icon to initiate it is available up there on the modeling toolbar, but by far the quickest and easiest way to activate it is just to click on an edge that you want to apply it to. So click on the edge, and then what you get is some quick access icons that are relevant to the thing that you've actually clicked on the model. And one of those icons is the round feature. So that's the quickest way of sort of working, if you like. So round, we'll set the round size to whatever we need it to. I think it was 25. Yep. So we'll double click, enter 25. That looks good. And again, if you remember back to when we were using the round feature, if I want to apply this 25mm round to numerous edges, I must hold down the control key when I pick the other edges. Because otherwise, again, if you can remember back, it puts all the edges into a separate set. And what that means is I can't do a bulk change in their radius. I would have to go through each set separately and change their radiuses to whatever I wanted it to be. Whereas if I hold down the control key and select an edge, the edges that I select with the controls key held, they're all controlled from a single value then. So you can see on my model, hopefully, I'm dragging the scale of that round and it's affecting the other edge as well. So it's just, if your intention is that they all share a same radius of curvature, then hold down control when you select them. So I'm rotating the model now without control held, but before I click on this next edge, I've got to hold that control key. So now I've got the 4 edges selected. So at that point, I'm happy with that round feature. I'm going to click on OK. Then I'm going to apply another round feature. So this one, I'm going to rotate my view round to what we are calling the base, or the underside of our it's almost like a Tupperware box is what we're aiming to design. So it's sort of a box to keep food fresh in, or something like that. So we're looking at the bottom face of it now. We want to apply a round all the way around the perimeter of the bottom of this. And one way that I can achieve that is to just click on one of those edges which form the perimeter. So let's say click on that edge there. Initiate that round feature again. So the round icon is right there. And you can see what the system defaults to. Because those arcs that were forming the corners there were tangent to the straight lines, the round feature just runs all the way around the outside of our box. So we only have to select one edge in this case. So let's set the value of that at whatever we need it, 15. So that's that one. And we can accept that preview. That looks good as well. So we've added the round feature, but we knew how to use that already. So hopefully that's just a little bit of a recap. So what are we going to do next? Again, we'll bring our reference back. So we're going to use that shell feature next. And you can see the difference. So this is what we're currently looking at, this top image here, which if I show you my screen, yeah, that looks okay. That's what we're looking at. It's a solid block of material. And the shell feature essentially turns it into a shell, which has a very thin wall, or a wall of thickness that you can define as the user. So this feature kind of needs 2 inputs. It needs a first input, which is what face do we want to get rid of? And for us, it's going to be this top face. So we're going to tell the shell feature, get rid of that face. And then the remaining geometry, what thickness do you want the wall to be? So you enter a value for the thickness of the wall. And that's kind of it. With the shell feature, those 2 inputs will be all it requires from us. So again, it's in the engineering section of the model toolbar up there. It's right next to the shell and the rib. The draft and the rib. Click on the shell feature. Again, it might be nice to sort of delve into a little bit more detail of how this feature is set up. So we'll click on references just so that we're aware. So we've got two broad sort of entry boxes here. We've got removed surfaces and then non-default thicknesses. We can disregard this. This is only used if you want to create a shell where the wall thickness throughout it can change. So maybe you want one of the walls at 4 mil thick, and then you want a neighboring wall at 3 mil thick, and then you get the idea. So we're not going to use that. But we are going to use the removed surfaces one. So I'll make sure that this box is selected by clicking on it. And then I'll select a face or faces from my model that I want to remove. So I've already said it's the top face. And then I should instantly get a preview because it's already got a default thickness value entered up there. It's not the thickness value that we need, but there is one in there. So you should instantly get that preview. And like all the other features in these more modern versions of Creo, you can click and drag and sort of see the effect that any of these values are having. So if you click and drag on that little sort of sphere or circle that's highlighted in yellow there, you can see in real time the effect that changing these values is having. And hopefully you can see how it's generating this internal set of surfaces. So these are new faces that didn't exist before. The outside of the box existed, obviously, but the top used to just be a flat, planar face. So what it's done is it's generated all these new surfaces on the inside, and then it's joined the two sets of surfaces together, the inner ones highlighted in orange, and the outer original ones highlighted in grey, and it's joined them together using this green face. So that's what it's doing. And the way that it generates the inner ones is it just takes a copy of all the outer ones and then shrinks them down to hit this thickness value that we specify. So there's a point where those round features, you can see them there, disappear. And that's because it's offset so far towards the center of that circular shape that it's past the center point. So there, the round has disappeared there. So that's a good little heads up as to how the system works. Or it's good to know that that's what it's doing, because that allows you to more easily debug problems that you may have in your designs if you're aware that that's how it generates these inner surfaces. So yeah, that's quite nice. But we'll set our thickness at the value that we need. So it's 1.5 is the thickness for us, I believe. I'll just double check. Yes. So we're now at that point. So I can OK the shell feature. And again, just like before, we're building up these features in the model tree on the left-hand side here. And if at any point we need to go back in and make a change in one of these features, we can do. So let's say the draft feature there, I'd like to go back in and make a change. I could just click on the feature. The edit definition icon is there, which is that yellow sort of sphere with a pencil pointing towards it. Edit definition, and it takes me back into the creation stage of when I was creating the draft. So I could put more draft on my model, I could put less draft on it. I could even pick some different faces to apply the draft to. And then when I click on OK, all those changes are run through into my model. I'll just double check that. Yes, they are. But I don't want to do that, so I'm going to click on undo so that my model should go back to the same as yours. So let's keep going. Let's see what we're doing next. So we're going to have a little play around with the rib features. And what we're going to do first is we're going to create a little sketch. We're not going to initiate the rib feature to begin with. So we're here, we've just okayed the shell feature. So create a new sketch on the front plane is what we're going to do first. And what we're going to create within that sketch is that sort of shape. So hopefully you can tell what we're looking at there. So here's this upright side wall of our box. So that is 1.5 millimeters thick. It travels down at a 10-degree angle there, so you can see it. It's got that lower round feature on it. It's still 1.5 millimeters thick. Then there's the base of the box there. You can see that. But this sketch is being created with the wireframe view style. So we can't actually see any solid material here. Our box is just being represented as just a series of, well, a wireframe model. So we need to switch that option on. And then what the shape that we're ultimately going to sketch looks like is this shape here. So you can see in yellow the actual sketch lines. And that's all we need to create the rib feature, that sketch. So this is, when we come to use it, you'll see there are similarities to the extrude tool, but the big sort of difference is that in these sketches you do not have to create a closed boundary of edges. So hopefully you can see that this is just a collection of lines that happen to touch the inside surfaces of the box. But the rib tool doesn't require that you create these lines here that I'm tracing now to close that shape off and create a closed boundary, like we have to do when we create an extrude. But in certain other aspects, it's very similar to an extrude. So we're going to create that first. And I'll just have a little look. Front plane is where we're going to create it. So I'm not sure that we've just created a sketch on its own yet. And probably the easiest way to do this is if we just click on the front plane. So I can click on it over here. Or if I can select it easily in the graphics window itself, I can click on it as well. So either one will do. So I'll click on it over here. And then of the quick access icons, you can see that icon there, which is sort of a wiggly line, a blue line on a grid, is the new sketch. So we want to create a new sketch. We want to create it on this plane. So click on that icon. It will rotate our view round. It's put our box into an odd orientation there, but that doesn't really matter for our purposes. There is a way to change that, but I don't want to sort of complicate the matter at this point. We will kind of look at how to... is it just on the front plane? It is. It's just been sketched onto the front plane. Just let me take a drink. I've got a very dry throat in this session. So let's do the first thing that I said, which is we don't want our part to appear with this sort of shaded effect on it. So currently it's set as shading with edges. So I clicked on this little icon at the top that looks like a cube, and that gives me access to all the other display methods that I can switch on for my graphics window, which is where I do most of my work. So the one that I'm going to pick is wireframe, like that, which basically it only highlights the edges of the part. The faces of the part aren't shaded in. So all I can see is edges now. So that's perfect for what I'm about to do. So what I'm going to do is zoom in a little bit to the area that I want to do some work on. Did I make a reference line? No, I didn't. Not yet, although I may do in a second. So I'm just going to center the bit that I'm going to do some work on. And then I'm going to get my image on my other screen just so that I can take a little reference of that. And then I'm going to get the line tool. So line tool, and hopefully you can see what's happening. When I get near that inner surface there, the system's offering me a coincident constraint. So that is exactly what I want. So when I get near it, it offers me the coincident constraint as a green icon, and then I'm just going to click. And then I'm going to go vertically about there, and then I'm going to go horizontally. And notice again, when I get to the exact same length for this horizontal line as that vertical line already is, it also offers me an equal length constraint, which is not what I intend for this line. So I want to try and avoid that. So I'm going to drop that line there. So it's definitely not the same length as the other one. And I'm going to go quite a lot further vertically like that, and then back. You kind of get the idea. You need to sort of emulate more or less what I'm sketching here. And then again, I don't want this line that I'm about to create here be equal in length to any other line in this sketch. So if you see the little equal sign in the green square visible, you want to move your pointer away from that, like that. And then I'm going to do one last line down onto that bottom surface, down there, sort of diagonally. And then I don't want to sketch any more lines, so I'm going to press Escape. You'll probably have to press it twice to exit the line tool. And then I'm going to add some dimensions in. So the first big one is the height of this thing, or as we're looking at it, the width. So this one here, this 32. So I want to sort of place that where it's reasonably easy to read, double click, and apply 40 millimeters to that one. Then I've got an angular measurement on my reference between here and here. So I don't currently have a weak dimension that's showing that. I've got an angle between these two lines instead. So what I'm going to do is get the dimensioning tool active. So dimension tool is at the top there in the sketching tab. Click on the dimension tool, click on the line that I want to dimension to and the edge of the base of the box that I want to dimension to, and then middle click or middle mouse button in the middle of them, and that should drop that dimension. And that one wants to be 60 degrees, like that. So we're gradually sort of building up the shape of this thing. So this one, again, I'm not creating new dimensions now, I'm editing existing. So I want to hit Escape to get out of the dimensioning tool. I don't want to add some more in at this point. I just want to edit existing ones. So that one there needs to be 4. This one here needs to be 10. This one back here needs to be 5. And the depth of that little cut in, so this one here has to be 4, like that. And that should sort of fully define the sort of shape and size and scale of our sketch that we've created. So what's going to happen next, we'll OK this sketch and then we'll initiate the rib feature. And the rib feature will give it this sketch as its input. And what it will do essentially is it will take this shape and it will fill the gap between this shape or this line that we've created and the part itself. And one of the options that we'll have is which side of the line do we want to add material to. Now if we add material to this side, the rib feature will fail because the material will fill out into infinity. It will just keep going and going and going and going and going off in this direction because there's nothing to stop it over here. But because we've created a sketch which touches these inner walls of our part, if we fill on this side of the line, the rib feature gets stopped by these inner faces of our part. So that's kind of how it works. But at that point, we're happy. So we can click on OK. And we've got our sketch there. And if we rotate around, we can kind of view it. The fact that it's shaded in green or highlighted in green means we've still got it selected here. We're not editing it, we've just pre-selected it, which is probably confusing matters. So I'm just going to click in some empty space over here to deselect it. So all sketches, when they're deselected, they have this kind of light blue color to them. That's assuming you've got the same color scheme on your Creo as I've got. But certainly on my version, these are all in light blue. So I'm going to initiate the rib tool next. So I'll just double check on our reference material. And what are we going to create? We are going to create I can never remember the difference between these two. So there's two types of rib. There's a trajectory rib and a profile rib. And I believe we're creating a profile rib. So if we look in the drop down there, profile. So we're initiating a profile rib. I'm just looking at the chat. Did that person who was asking about reference lines solve that problem? I think it was Sam. Yep, very good, very good. So yeah, it's looking for some input. Again, we got to a point now where I think we're confident enough that whenever we create these features, it's probably worth just having a look at the full detail of the feature. So in this one, there's not a great deal of extra detail in these tabs, but it's worth clicking on these tabs just to investigate. Is there something I've missed here? What's it waiting for? What it's waiting for is some input into this box entitled sketch. And if you do want even more info, it'll give you a written description of what it's waiting for down here. So select an open sketch. So that will be a sketch which doesn't form a closed boundary, which is what we've created. If an internal sketch is preferred, the define option can be found. Yeah. So in some cases, you wouldn't create a sketch initially. You'd just initiate the feature and then create a sketch on the fly, sort of as you were working. But to illustrate the point, we created the sketch first, just to see what the sketch is and what's unique about it and all that sort of stuff. So make sure you have the sketch box selected. It should be already pre-selected in green anyway by clicking on it, and then just click on the sketch that you want to use. And at this point, just because there might be a bit of ambiguity in what I'm looking at there, I'd probably turn the system back to shaded with edges so that I've got my sort of what I consider my default display style. So click on display style there, switch it back to shading with edges. That's more like what we sort of become used to. So you can see the preview there. You can also see that my system, at least, has picked the correct side of the rib shape to add material to. You can see that little pink arrow pointing downwards. And what that means is it's picked that closed area that is made closed by the sketch and the part itself. So the part, in a sense, forms the closure side of our sketch. So the sketch itself can be open. Now, if I click that arrow, yeah, the feature fails. The feature cannot rebuild. Because as I said before, the concept here is it's just filling from that line outwards until it meets some of your part. And there isn't any of our part up above, so it fails. So we want it filling downwards. So now all we have to do is give it a thickness. So what is the thickness? 1.5 again. So if we double click, set that to 1.5. And then just for completeness, so we know that this option is available if we ever have to use it in the future, you can see our sketch is kind of sandwiched in the center of that rib. So the rib has added that 1.5's worth of material as 0.75 on one side and 0.75 on the other. We can change that. So you can see there I'm clicking on these arrows after the 1.5 up here. So you can go one side of the sketch, you can go mid sketch, or you can go the other side of the sketch. Yours is going towards the opposite wall. That is interesting. Is there any chance that you could share your screen if I switch my sharing off for a second? I'll just stop sharing if you want to do that. Yes, okay. Oh dear, right, okay. So that is that the right? No. So you've inadvertently picked the wrong type of rib there. So let me back out of what I'm doing and I'll share my screen. So yeah, I can solve that. Just let me reshare my screen again. So there's two types of rib, and they're in the drop-down menu there, and it's not immediately obvious which one you're going to get if you just click on rib. The two types that are available are trajectory rib, which is what you've just selected, and profile rib, which is what we're using. And we're doing profile rib at the moment, but we're going to use the other style in a second and show the difference between the two. So you've inadvertently gone into the wrong one. So if you back out of that, just cancel it and then go into profile rib. So the little icons there kind of give you a heads up as to what sort of thing you can create with each one. One kind of fires off in a single direction, and the other one is a little triangle, similar to what we've got here. So, yeah. So you select the correct one, the profile rib. You can see it at the top of my screen there. Select the sketch. Make sure the thickness is the value that you want. Make sure that the thickness is being added either to one side or the other of your sketch, or to the mid plane, which is what we want. So we want it like that. And the way that you cycle through those options is just click on that button at the top there, and you can see I'm sort of cycling through the 3 different options. So it's that one, it's the mid one that we want, where the sketch ends up sandwiched within the rib itself. So click on OK. We've got our rib feature then. It gets added into the model tree. The other behavior that it's just worth noting of the system is that you can see the sketch that created our rib, that sketch 1, is now being hidden by the system. So that it does that as default. It hides any sketches that you use to create it. So if we had a need to view that sketch at any point, we could just click on that grayed out sketch icon and just click on that little eye, which means show, and it would show the sketch again. So you can see it in blue there now. And then likewise, you can click on it again and click on hide, and it will make it disappear. So yeah, that's kind of the default behavior when you use a sketch that you pre-created to create a feature. It hides that sketch. So let's have a look at where we're going to go next. So we're going to use the other rib type, the trajectory rib. I always have trouble getting that word out. So what we're going to create this time is we're going to create a series of lines looking down from above onto our part. But before we do that, we're going to actually create a new line, new plane. Sorry. So up until this point in all the tutorials, we've either been creating sketches on the base planes themselves, so the primary planes, the right, the top, or the front plane, or on the odd occasion, we have been sketching directly onto the face of our model. So those are the 2 ways that we've created sketches up to now. But what we can also do is create our own planes. So in the same way that the top plane is there, we can define our own plane that we can have in any position that we want. So that's what we're going to do for this feature. So how are we going to do that? One of the ways that you can do that is you can create a plane which is a set distance away from one of the datum planes, or from one of the base planes. So that's what we're going to do in this example. So you can see at the top there in the modeling toolbar, there's a section called datum, and there's a plane option in there. So that's what we're going to click on. And then this little box pops up, and what that's asking for essentially is some references. Now, the type of references are wide and varied. You can select edges, you can select points, you can select bits of sketches, you can select other planes, you can select, I believe, coordinate systems as well. So there's a lot of variety in here, and we'll use this tool time and time again. But for this example, all we're going to select is one of the existing datum planes. So we're going to select the top in this example. And that's all we're going to need, other than just an offset value. So you can see translation away from the top plane. So I forget what the figure is for this, so I'm just going to drag it to a reasonable level. So something around there. I don't want it to line up with the top edge of this rib. I want it to be different. So yeah, something around 34 millimeters is fine. So 34 mil, you can see what it's doing. It's giving you a preview in yellow there as to where that plane is going to end up. And if we, well, now we'll not get into the normal direction of planes, but yeah, there's an arrow there to set that. So we're happy with that largely. At 34 millimeters away, we'll click on OK. And it gets named as datum 1 or DTM1. So that is what we're going to create our sketch on now. So we're going to click on the plane, select the sketch icon, which is the first icon in the middle row of the icons there. Our view should then rotate around so that we're looking at 90 degrees to that plane. And then essentially all we're going to sketch is a collection of horizontal and vertical lines. So this is what we're going to sketch. And these lines, so if you sort of get those in your mind, there's one attached to the inner edge there, there's one that goes beyond the inner edge, there's a couple of points here that don't quite make it all the way across to this edge, are going to create these rib features. And there's a sort of reason that I've sketched them like this. They appear a little bit sort of muddled and there's not much logic to them, but it kind of illustrates what this type of rib does. It will extend lines that don't quite meet the inner wall of your part. So you see the end of this line here doesn't reach this wall over here. But the trajectory rib will extend it so that it does meet that wall. And likewise with this one, which doesn't quite meet that inner wall there, it will extend it so that it does. And this one, because it goes beyond the inner wall, it will trim it back for us so that it hits that inner wall and no further. So that's kind of the behavior of what this tool does. So it's quite adaptable to, you sort of give it what I consider quite a rubbish, messy sketch, and it kind of tidies the overhanging bits up for you. So let's try and create that. The actual values in here aren't terribly important, but we'll try and duplicate them. So I'm just going to recenter my view a little bit, like that. I'm going to get my line tool. I'm going to sketch from outside the part about there and go all the way down to around about, I might need to zoom out slightly. Zoomed in a little bit too much there. Somewhere about there. And then I'm going to hit escape because I don't want the next line to be joined onto the end of that one. But I only hit escape once. So that has the effect of it terminates my sketching of lines, but it still keeps me in the line tool. So I can now sketch a second line. So I'm going to attach this to that inner face there. So you can see that inner face highlighted in green, and you can see the coincident constraint being offered in green also. So I want to stick it to that inner edge there, and then sketch across to around about there, and then press escape again. And then what am I going to do on this one? I'll have a line that goes up there to around about there. Press escape. I want to sketch one that comes down to about here. Press escape. And I think we're complete there. So we've got a few lines there that don't quite meet the inner walls. So this one is short, and this one is short, and this one is short. We've got one that does meet the inner walls, so that one's quite good. And then we've got one that overshoots and goes beyond the boundary of our part. So I'm going to hit escape again because I don't want to sketch any more lines. And then just in this instance, I don't think we'll set these values to the values that I had, because we don't really need these values to be a specific value. This is just an example of how the tool itself works. So as long as you've got something that sort of scale and shape, that should be good enough. So I'll leave that on the screen for a second. As I say, it's just to illustrate the behavior of how this type of rib actually works. So let's OK that sketch and get out of that sketch. And then if we rotate around, you can see it's placed on that datum plane. So it's on that new datum plane that we created. So that's its height above the bottom of the box, if you like. So let's select the rib type that we want, the trajectory rib. Select it. Click in the placement tab to see what it's asking for. It's just asking for a sketch like before. So we have a sketch to click on. So we'll click on that. Then we get a preview of what it's going to do. It looks like it's done its job. We're seeing that behavior that it performs that I kind of talked about before we came in here. You can see where this sketch ends there, but because of the function of this tool that we're using, this type of rib, it extends these ribs till they meet the inner first surfaces of our box. So it's just worth being aware of that. That's its sort of function, to sort of tidy up your messy geometry. And it trims this one back as well, obviously. So what are we going to be directed to do next? So we got to this point. We can set a draft angle on these ribs, because obviously if we're talking about draft angles and we're talking about trying to remove this injection molded part from a mold, it would be useful to put a draft angle on all vertical faces. So it would be useful to angle them all. Now, this type of rib tool has that built into the actual tool itself. So you don't have to add that draft on afterwards as a draft feature. You can just activate it within this type of rib. And it's just there at the top. Under the word settings, there's a setting that adds draft to it. And when you click on it, hopefully you can spot what it's doing to our rib shape. So it's picked a side of the rib to expand to create the angle that we require. So again, back to our reference, I should read what I've directed myself to do here. We've created the sketch. We see now it extends the lines and now it trims the lines back. We're going to set the rib thickness to 2 mil. We're going to add draft to the rib. We're going to have a little poke around inside some of the other options in the rib and see that we can view its shape. And we're going to set the draft angle to 3 degrees and add a little internal round at the bottom, which will become apparent what that is. And then we're even going to add an external round as well. Okay, so we kind of know what we're going to do now. So first thing, we want to set this draft angle to the figure that I've said, which is 3. Then we want to set the thickness of the rib to the figure that I decided on, which is 2. So you can see I've edited both of those values now. And then what we're going to do, we're going to have a look inside these other tabs that allow us to browse through some of the other options to do with this type of rib. So the first one is shape, and you can see that gives you a nice little readout or schematic of what the shape of these ribs is currently set at. You can see my draft angle there represented sort of graphically. You can see my thickness, and you can see it applies that 2 mil in this instance to the top thickness. So it adds material to the base. So what are the other options that we've got here? Round exposed edges. Let's switch that on. And you can see the difference that that makes. So it adds a little round feature. So again, this is saving your use of multiple features. So if these weren't available in here, we would have to add a draft feature in after we created the rib. And then if the round wasn't available, we would then have to add a round feature to the tops of all the ribs, which would be a really tricky little exercise in clicking on edges. So it's good that they've been included within the rib feature. And then we've got round the internal edges as well, which adds this nice transition between the rib itself and the base sort of geometry of our box. So I think we're going to leave all these switched on. So what have I directed us to do? Internal round of 1 millimeter. Yes, we have that set. External round, we'll have that a little bit smaller. Top round, so you can see here, we've got it set as 2 tangents, which is essentially doing this full round across the top here. If you want to specify a value, you select the box and then you put 0.5 in there, for example, and it will change that value. And you can see in the preview in the background what it did. So it's left a little bit of flat on the top there, and it's put a radius of 0.5 mil on each of the shoulders there as well. So yeah, That's quite good because it sort of rolls a lot of features into one. So you can set them all up from a single kind of dialogue in here. So I'll just double check that there's nothing else to do in there, and I think we're good. So we'll click on OK. We'll get our final design visible. You can have a little look at it, see what's going on. And then at that point, I think if we take a save, just to be on the safe side, it's always good to save regularly. And I would recommend once you get into your project work, do that religiously. Just keep pressing save because you can always free up some disk space by deleting old copies of your part. But inevitably, the system crashes occasionally. And yeah, you want to save regularly. So I'm going to click on the save icon at the top. It's going to navigate me into my working directory that I set to begin with. And then I'm just going to click on OK. So I've saved a copy of that now. So I'm secure that I've got a copy of it should the worst happen. So I think, should we do relations next? Yeah, we'll move on to the next bit. Did everyone manage all that? If I can get a few yeses, or if anyone got sort of left behind, just shout up. But obviously, this has been recorded, and I'll upload it as well. And I think so. Let's just have a look at the learning materials. I think that in this link here, there should be this exact lesson somewhere, if I can find it. No, it's on the title page, but you should be able to recognize it. So I've backed out into learning materials. Where is it? I was sure it was on here somewhere. Maybe it isn't. I'll put that up there for you anyway, but you'll have a recording of this session, so it's not too desperate that you have that one as well. I could have sworn I'd uploaded that. Saving your files, simple rounds, sweeps, patterns, holes, drafts and shell. There we go. So there's one at least covering drafts and shell tools. And yeah, you'll have a record of this session, so you'll have some reference. Yours won't save. Failed features and model is not regenerated. Oh dear. Right. Okay. It's hard to know what to do there. You sort of need that model so that we can continue on to the next section. So are you able to share that then? Just let me unshare my screen and I'll see if I can help. Right, let's have a look. So it was the draft feature that had an issue. So if you want to, can you OK that dialog that's popped up, or even cancel it? Just get rid of it however you can. And then if you click on the draft feature that has the error icon at the side of it, so on the left-hand side in the model tree, where you've got your list of your features, if you go up to the one that seems to have, and then click on the edit definition, which is that icon. Brilliant. And then just rotate your view around so I can sort of see what's happening a bit there. And then if you click on the references tab at the top there, so you've selected some surfaces. Aha, right, okay. I'm not allowed to click on your screen, am I? No, I'm not. Right, okay. Let's start afresh by, if you right click on where it says individual surfaces and remove them all. So let's make sure that you've got the correct ones here. So pick all those 60mm high faces. There's 4 of them. But on yours, there's some reason there's 2 of them. Right, okay. Keep picking them. Keep going round. You've got to hold control down to get them all. So you've got them all selected. So then go down to the draft hinge box up at the top there. And so you look as if you've got the right surface for the draft hinge, which is highlighted in green. And then, but the pull direction's gone all strange. It's pointing sideways for some reason. I'll tell you what, delete the draft hinge as well. So right click on the draft hinge and remove, and then reselect the face which, so if you rotate, yeah, that face, the bottom face there. And then rotate your view so I can see that pink arrow again. Yeah, it's got a weird direction reference. So can you right click on the pull direction and delete that? So see if it'll let you delete that. Right, now select the same face which you selected for the draft hinge. So rotate around so you're looking at the bottom of the part. Yep, that one there. And that looks like it's going to work now. And then increase the angle to 10 degrees. See what that does. And press enter. Yes, it's working. Yeah, you just need to flip the direction. That should fix a lot of what was wrong there. But it's broken everything else. Right, okay. So, right. So that second draft, you shouldn't need it. So draft number 2, you should be able to right click on that and delete. Yeah, but it's going to kill all the other features. Oh, dearie me. Right, so yeah, you're working now, but you've lost a lot of features there. So yeah. You may be sort of watching the playback of this, having fixed all that, possibly. Yes, yeah. There may be an option there if you press undo a couple of times so that you bring back that second draft feature, and then try deleting the first draft feature that we edited there and doing all of those same edits, but do them to the second draft feature instead. That may work for you, but you've sort of tied yourself in knots there by creating 2 draft features. Yes. But yeah, there's always the video to refer back to, so you can always sort of loop back and do it at your own pace if necessary. So yeah, unfortunately, that's quite a big problem. But you can always watch what we're doing, I'm sure. So we were at this point. So what are we going to do now? We're going to have a little look at the use of parameters and relations. So relations between different parameters. So let's have a look at the sort of guidance PDF that we're kind of working through. I'll just shut some of my tabs down. So where were we? We were here. So we have our box design. We've put a lot of static values into there. So we've manually entered things like thicknesses and dimensions of our rib feature as well. We put a lot of dimensions into that first rib feature. So those are what I'd consider sort of static values. They're user entered values. But what you want to do sometimes is you want to calculate certain values using other values in your design as a starting point, and then maybe apply a little equation to that original value to generate your other value. And this is a good sort of description of what you can do with the relations tool. So relations in Creo, they have a different name in different CAD systems, but within Creo they're known as relations. And you can relate one parameter to another using some sort of mathematical operation, if you like, which essentially is what's said here. The parameters tool within Creo allows the creation of alphanumeric or logic, that would be yes/no questions, based data. So we're going to use a lot of numeric ones here, but you can put some logic into these as well. And they can be stored inside your Creo part. So we're going to have a look at that first. And then when we've had a look at that, the relations tool allows users to create links between different parameters. So those parameters could be things such as dimensions, but they could be things such as answers to a yes/no style question as well, which allow parts to change automatically, in inverted commas, with minimal user input. So it's not with no user input, but it minimizes the amount of user input that's required to auto sort of modify a part. So here we come to what we're actually going to do. Open the part created in the previous tutorial. We already have it open, so we can skip that step. changed the active tab from models to tools. So that's a new step. We've been in the models tab at the top all the time up to this point. We're now going to jump across into the tools tab, select the parameters tool, and then, yeah, so we'll jump in there. So we got a little heads up of what we were going to start doing. So I'll leave that on my other screen and we'll keep referring back to it. So what are we going to do first? We're going to go into the tools tab. So there's the tools tab. If we click on it, we get a whole different menu to the one that we've seen so far, the modeling tab. Within there, there's two buttons. There's a parameters button and a relations button. We're going to tackle parameters first. So if we click on the parameters button, so what we're looking at here are the two default parameters that are included with all new part files. So the system includes these as part of the template that we're using for our part files. And they are a parameter which is a string of alphanumeric characters. So this is the entire alphabet, plus all the numbers, plus a selection of the symbols on the keyboard as well. So alphanumeric characters as a string. And the name that it's given to this value is description. So this would tend to be, it would be a sort of wordy description of what this is a model of. So you would add maybe several words in here to describe this. So I don't know, for our example, we could put a box made of plastic or something like that. You get the idea. That's not a very good example, but this data can often be used when you come to create a engineering drawing of your part. So you come to create the engineering drawing and you have a gap on the title block of that drawing, which you would normally insert some sort of written description of what the part is. And rather than writing it on the drawing manually, you would tell the drawing sheet that it can access that data from within the part itself. So you would attach these parameters to the part itself. And you can see it's looking within the part. What part is it looking within? It's looking within the part that we have open. And that's what I named my part, draft shell ribs. That's the name of the part. So anyway, you can enter your own value in here. It also, by default, provides you with one which is intended for the person who created this part file to kind of sign it. So normally the done thing on engineering drawings is you put your initials in there. And again, these are really useful. They're useful for keeping track of who claims to have modeled something, but they're also useful when you come to produce drawings. You can access this data from the drawing. You can enter it automatically into a box on the drawing. Who was it who modeled this part? And there's an initial that just pops up there. So those are the default ones, and you can add your own data into them, into the values column. So we're going to add our own now. So what are we going to add? So we talked about the description and the model by. We're going to add our own row. So we're going to click on the big plus sign at the bottom there, which is add new parameter. We need to name this parameter first, unless we're just going to accept the generic name parameter 1, which we're not. So we're going to call our parameter wall, and then underscore symbol, and then thickness. I put, yeah, like that, wall thickness. Because what we're going to use this to drive is the actual wall thickness throughout our part design. So what are we going to set this as initially? So we'll set it as 1.5 initially. In fact, let's be a little bit different. Let's set it as 3 initially. And then hopefully when we apply this, we'll see a change within the part, because currently a lot of the part is set at 1.5. So I'm going to set this as 3. I may come to regret that later on. I forget what other operations we do later on, but we may come back in and change that. And the type of value that I've allowed it to accept there is a real number. But you can see I could have changed that to an integer. The string is back to our alphanumeric string of characters, so that wouldn't really be suitable, because this needs to be related to an actual number, a dimension. So real number is fine for our purposes. And then we're going to click on OK. So we've created our own little parameter which is stored within the part itself, and we've named it as wall thickness, and we've given it a value as well. Mine's defaulted to 0 there, so make sure it's 3. So now we're going to click on OK, and we're going to go into relations now. So we've added a parameter, we've filled in some of the default parameters that come with every new part, so we've done those 2 actions. Now we're going to go into relations. So you probably won't be able to see that little drop down that I had visible there. So I'll hide that initially. So what are we going to do now? We're going to select one of the dimensions on our part because we want to put a relation in which allows the system to assign a value to one of the dimensions in our part. And the dimension that I'm going to choose is the thickness of these ribs here. So I can either select them over here in the model tree. I could click on them there, although it's not letting me see the dimensions. Probably easier is if I double click. No, try again. This was working earlier. Try this again. Ah, there we go. Right. So I'll do that again. So I clicked on the relations sort of entry box here, this big white area. So I clicked on there, and then I clicked on the feature that I wanted to view the dimensions of that feature. So I clicked on this rib. And what happened, and hopefully what you're seeing, is all the dimensions that are driving that feature. So you can see there's dimensions here related to the sketch shape that I created. So you can see the lengths of the lines in that sketch are all dimension there. There's a dimension there which is obviously the thickness of the rib because it has the word thick after it as well. But these are the internal codes that Creo keeps track of these dimensions by. So you can see they all start with a D if they're just plain linear straight line dimensions, and then they have other designations if they're not a linear straight line dimension. So a good example is the thickness. That has a specific sort of significance because it defines the thickness of something. There's ones here which have an R in front of them, and that designates that they refer to a little radius. So there's a round feature in there that has a radius, so it gets that capital R designation. But these are the internal codes that Creo keeps track of all these parameters, which in this case happen to all be dimensions. So the one that we're going to play around with here is the thickness. So I'm going to just click on that there, just once. And what you can see is that then gets transposed up into my essentially little text editor window up here. So I've collected it. That D35 has been entered up here automatically. Now I could have typed that, but it tends to be easier to find it on the model and just click. And at least then you know you've got the one that you've highlighted on the model. So what am I going to do next? I'm going to put an equal sign. So this is very similar to when you're setting up formulas in something like Excel or another spreadsheet. So I'm going to say I want D35 to equal something. And the easiest way to tell it what I want it to equal to, or be equal to, is if I have a little look inside this local parameters arrow, I want it to be equal to that. So I want it to be equal to what I've named as wall thickness as a parameter. So the way that I insert that up here, I could just type the name of it. But again, I'm a sort of lazy CAD operator and I want to insert it automatically, which you use those bracketed sort of brackets on that button there. Insert parameter name from the list. Click on it, you get a full list of all the parameters stored within the part. You click on the one that you want and you click on insert. So now what's happening, so if I click on OK there, just to temporarily get out of that, nothing appears to have changed on the model. And the reason for that is that you have to rebuild the model. The system has to run through its list of features and apply any changes that have been made by you, the user. So you can force the system to do that, and the button to do it is there. It's right on that top sort of menu bar. You can see there's a keyboard shortcut as well, which is Control and the G key, but it's that one there, regenerate. And when you do that, keep an eye on the thickness of the rib because it should update. There. So all those rib features all are now controlled by that parameter value. So that's the first bit of what we've done. So we've tied them to a parameter that we can then refer to control other features. So we could use it to control the thickness of the box as well, and the thickness of this rib as well. And this way we're sort of tying them all to a single value. So if we make that decision that they all must all stay the same, the easiest way to drive them all is to edit them all at a central place, not to go into each feature individually and edit each one individually. So where are we going to go next? Edit. Click on the shell feature. So I think we'll apply that to the shell feature as well. So let's click on relations again, and let's press the enter key to get a new line. And then we'll select the shell feature itself. So I'm going to just click on the sort of inside surface of the box itself. And there you can see the only real driving dimension in there is the thickness of the shell. So it's saying D7 O thick. So I'll click there. It collects that D7 value. Then I put my equals sign. And then again, because I can't be bothered to type wall thickness, I could do a copy and paste, or I could insert it the same way that we did last time. I could go to those dual brackets. That's the button that inserts a parameter. Click on it. It gives me a readout of all the parameters of the part. So this would be useful if I'd created multiple parameters and I couldn't quite remember the name that I'd given each one. I could find them quite easily and then insert. And then I think we'll do it one last time with the other rib. I think that's how I progressed in this tutorial. I'm just wall thickness parameter, yeah, 2 ribs. So we'll link the other rib in as well. So I'm on a fresh line here, select that other rib, and then zoom in a little bit. See if I can find the thickness value, which is not as easy on this rib. I think it's that D14. Yes, that looks right. So D14. And just to add a little bit of more interest, what we're going to do with this one is we're going to insert wall thickness, but let's hope this works. So I just did a copy and paste there. Let's do wall thickness multiplied by 2. So I've just used the asterisk key and put a 2 at the end. Let's click on OK there, and then we can do a rebuild on our model and see if it actually does what we think it's going to do. So rebuild, yes, it seems to do that. So not only can you put these simple equal relationships between values and between a value and a parameter, you can also put formulas in there as well. So let's go forward. So the sort of final section of this is all the wall thicknesses will regenerate to 1.5. Well, we've sort of overridden that now because we've illustrated that we can do a calculation as well. We can have one of the wall thicknesses related to the others, but a certain ratio of the others. So we can add a formula in there as well. So the task is make the height of the box half the depth of the box. So that's the first thing that we're going to do. So let's have a go at that. So what I'd tend to do here is, because this is just a simple sort of text editor here, you can put spaces in there if it makes your life easier. So I've put a double space because all of these sorts of relations are all kind of related to each other. They're all of a similar type. They're all using a similar parameter. So the next set that I'm about to create kind of aren't related to them. So I put empty space between that and what I'm about to do. So what did it say? Height of the box, half of the depth. So the box feature, we need to try and make that visible. So if I click on the outside of this, so that is the draft feature. So that's not what I want. So let's see if we can click on that original extrude. There we go. So the way I did that was I clicked in my entry box over here. So I'm making sure I've got that box selected. And then I found the feature that I want to edit something on, that original extrude in the model tree. And then I clicked on it. And all the defining kind of dimensions and parameters related to that were shown. Now, the fact that I had already clicked on the draft there means that I can also see the draft angle, which is not relevant, but it's just sort of telling you that that's the reason that that's there. So, height of the box, half the depth, right, okay. So we're going to calculate this value, which is the height of the box. So collect that, and then make it equal to, I'd consider that the depth of the box. The depth of the box, either divided by 2 or times by 0.5. So that's how we calculating that. So D0, which is the height, is going to be equal to D1, which is the depth, divided by 2. So we can see if that's actually going to work. No, we can't do a rebuild from there. So I'm going to OK that and then do a rebuild. It seems to have worked. So let's see if we can ascertain that. So that value is now 65 and that's 130. Seems to be working. And I can check this. So I could edit that 130 and maybe bump it up to 200 mil and see if the height of the box actually changes. Yeah, it does. So you can see now this is 200 and this is 100. So we put a relationship between those two values, which again, if you can think out and apply logic to your design and try and apply these relationships in your design, then you can instigate them in the CAD system and you can make editing this design very automated. You can automate the process quite well. So what else have we got? Make the height of the second ribs 60% the height of the first rib. Okay, let's see if we can do that now. So I probably do a refresh or a rebuild so that I get rid of all those values that were on the screen. Then I drop back into relations. I maybe would class this as a different type of relation, so I go to double space between this and the last one. So the height of the second ribs should be calculated from the height of the first rib. So what I want first is the value that's defining the height of this second rib, and that value is governed by the position of that datum plane that we created. So that datum plane is a set distance away from that top plane. That's how we defined its position. So it's actually the height of that datum plane that we want to calculate. And we want to calculate it as 60% the height of that rib. So let's see if we can do that. So I want to click on the datum plane. The parameter defining the position of the datum plane becomes visible. There it is, D27. Click on it to collect it. We want to make it equal to the height of this rib, which if I click on the rib, all the parameters defining the shape of the sketch and the width of the rib become visible. So that one is the ultimate height of it. And then I will probably multiply that by 0.6. And that should do the job. Can D25 equal D7? Ooh dear. Which one is D25? D25 equal D7. Which dimensions are those? I can never be sure if your systems have assigned the same dimension labels as mine has. That's one sort of
Mine haven't.
Yeah. So the specific dimension labels that I'm talking about here, your system might be slightly different for whatever reason. So it assigns these labels based on a certain amount of logic, but yeah, tiny changes between what I've done on my screen and what you've done on your screen could have led to a slightly different labeling scheme on your system. But essentially, the concepts that we're sort of achieving are kind of outlined in the instructions. It's just that the the actual labels for each dimension may be slightly different. But yeah, if you're having trouble, you don't have to necessarily do it in real time. You can watch the playback. You can kind of do yours at your own rate then, and hopefully you'll sort of be able to do it on your system. So let's just do a refresh and see if the height of these changes. Yes, it appears to have worked, at least on my system. So if I just interrogate what the height of these is now, so where is it? The height, oh, it's the height of the datum plane, sorry. So the height of the datum plane is now 24, and the height of this initial rib is 40 for some reason. Oh, that's interesting. Yeah, definitely 24. Yeah, because it's not a simple half relationship, it's 60%. So yeah, that appears to be working now. So, and the sort of last little bit of this is that if I was then to make the decision, hang on a minute, one of those relations, I don't want it anymore. I want to have total free control over, let's say, the height of these ribs, totally independent of the height of that rib. If I was to click on that datum plane and go edit definition, it locks me out. So because a relation already exists to define this value, it won't let me now change it. And similarly, if I try and go into, I don't know, the shell feature and I can't double click on that. That one's been locked off from my influence. So you have to kind of disable any relations that you've put in to control these values before you actually get access again to be able to change them. Is there anything else that we need to know there? Yeah, there's kind of one last bit of this, which is when you're dealing with relations here, if you, let's say you want to collect some dimension off the model. So I'm going to click on the model now and collect a dimension from it. So let's click on this first rib. I'll just go onto a new line on my entry box there. So I'll click on that rib shape. I then get to view all the dimensions that made that rib. I'm viewing the labels that the system has applied to them. But let's say I want to actually view the values instead. So you can do that as well. There's just a switch dimensions button on the top menu bar there. And what that does is it toggles between the labels that the system gives everything versus the actual dimension values themselves. But if I click on them, it still collects it as the label that the system has given it. That's just for me as a human to be able to read them a little bit more sort of logically, so I can spot the dimension that I want. So yeah, you can switch between the two. That's kind of the upshot there. You can just toggle backwards and forwards. So that might be an easier way of you sort of replicating what I've done to view the actual figures themselves rather than the system labels that have been assigned to them. So what's the last little bit of that? So the last little bit is just the simple task where why don't you add a parameter to define the part surface finish as matte? So yeah, we should be able to achieve that at this point. So it's a parameter, so we go into the parameters menu. It's a new parameter that we want to add to this list that we have of different parameters that are attached to the part. So we know how to add a new parameter. It's the plus sign at the bottom of the menu there. What do we want to name this parameter? So it's going to be, I'll probably abbreviate it to part finish, something like that. So again, these are useful. These sort of alphanumeric parameters are quite useful when you're creating engineering drawings. So these are the sorts of things that you can pull straight through into the engineering drawing and stick it on the sheet, and it will be auto filled in. You won't have to then manually enter it into the drawing title box. So it's not a real number, it's just a string of alphanumeric characters or ASCII characters. Part finish, matte, like that. So we've added that in as another parameter. So yeah, parameters can kind of do both of those jobs, or they can do a job which is off the top of my head, I think we've done in another tutorial this week in a different CAD system. We added one in, so I'm adding another one in here. Purchased, as in, is this part that we're looking at bought in to the company, or is it manufactured by us? So purchase, that would be a yes/no question, and you would just set it as either yes, we buy it in, or no, we don't buy it in. So you've got that option as well. Parameters can sort of keep all of that. And if you want to think about it like this, these are stored inside the file itself. So wherever the file goes, if you send the file to someone, these parameters go with it. So they're a type of data that you can add to files that generally is more widely known as metadata. So you have metadata attached to digital photographs and things like that. You can have the GPS location that the photograph was taken on, or the camera hardware that took it. All of that is considered metadata. It's additional data. It's not the main file itself, but it's attached to it, and it goes with it wherever you send it. So yeah, that's kind of what parameters are, certainly in Creo. So I don't think we want to get into sweeps and parallel blends right now. We have kind of got 15 minutes, I think, so people can, if you've got any kind of burning questions about any of that, I can try and answer them. But I was going to sort of point you in the direction of the project or the assignment text that I should have released now. So I can go through that a little bit with you and talk you through quickly in the next 15 or 10 minutes, just the general outline of the assignment, if you like. I think that might be quite useful. I think I will do that. So take a save of that part, especially if you didn't quite complete it as we were doing it there. And you can always drop back into that yourself in your own time and watch back the playback of this session as well. So if you want to save it, just click on the save icon at the top. Everything about that will then be saved to the working directory. And I'll get my copy of Shoe Space visible on the screen. So if we have a look in the Advanced CAD-CAM section of Shoe Space, there's an option there that says Assessment. If I click on that and give it a second to pop up. Now I believe I've released this so that you can view it. Yes, I have. So I'm going to add a little bit more info into here over the next week or so. I'm just speaking to last year's course leader just to confirm what extra info you need. But this is the general outline of your assignment. So it's a PDF. You may have seen these already. The first thing that needs changing is that bit at the top. So that needs changing to this here. I thought I'd actually uploaded the newer version of this, but nothing's changed on this. So I'll just double check that this is the correct version. Yes, it is. So I will upload an updated version with the new hand-in dates and all of that business on here. But the interesting bit comes further down the page where we actually get the tasks that you are requested to perform. So there's a little intro here. It's talking about this brief was revised last year when we went to offline teaching, or we went to remote teaching. So that's just a little intro to do with that. Tutorial classes, it's just outlining that these classes that we have in the tutorials will give you the skills to allow you to complete this assignment. There's a little bit about submission of work, which we'll get into when I've set up the submission point. So the following activities detailed below, your task to design, analyze, and discuss the preparation for manufacture of a retractable utility or craft knife. And there's an appendix with a little typical drawing of such a knife. So if we just temporarily skip forward to that appendix, and we'll have a visual representation of what we're kind of talking about. So it's this type of knife, which is common on the market, and the task is basically to design something similar to this that performs a similar function, but you have certain constraints that are put on your design. So this document lists those constraints, and what you're expected to do is create that design within Creo. So using the modeling tools that we're going to work through in all the tutorial sessions. And then later on in these tutorial sessions, we'll look at using some of the analysis tools within Creo to refine your design and optimize your design and try and hit some of these parameters that you're going to be set to hit. So you can see here, there's various parts to that knife. There's the main body back and the main body front. There's a locking slider mechanism that slides the blade in and out. There's a rear cap that attaches to the back of the knife design. And there's also a cutting blade that you will be given a file that is the cutting blade. So you can see there's an IGES file, which if you watch this week's lecture, which is up online now, it talks about IGES files. So that's a file that you can import into Creo. It's already been created for you. So you've got these various constraints. You've got constraints on weight. You've got constraints on dimensions. You've got various other constraints that are outlined further on. You've got things which are more sort of qualitative than quantitative, such as the ergonomic and aesthetic styling of the thing as well, which some of the later modeling tools that we're looking at will allow you to put a little bit of sort of aesthetic modeling into that design. So the design of the front body, so now we're focusing on the individual parts of the knife. So we have the front body cover that I would consider that part of the knife, and it's been labelled there. There's the front body, and then there's sort of a mirror image back body that has some of the features of the front. It fits together with the front, but it obviously doesn't necessarily have this slot for the slider. So back to where we were again. So we're talking about the front body. We're talking about some of the things that it has to sort of satisfy. It's got to have recessed located notches or features to incrementally position that slider along its body. So you get the idea with these knives that you can slide the blade out and then you can lock it at a certain point. So you have to design some form of locking or notch so that you can positively locate that slider. You've got to put some consideration for left and or right-handed use. Ergonomic styling for comfortable use, which again is somewhat interpretive, but you've got to make some sort of attempt at that and put it in your report. 1 millimeter clearance channel for the blade. So you get the idea. There's lots of sort of design points that you have to address with your design. And the expectation is you'll do all this design work in Creo, you'll create these parts, you'll refine them, you'll come up with a final design that's been somewhat optimized and refined from your original design, and then you'll write a report at the end or as you're going through, and it will address each of these points, and you'll make some kind of change or addition to the design to address each one of these points. So I'm not going to go through every single one of those here, but you can see they're split down into body back cover, the rear cap of the design. One of the things that's worth sort of mentioning about the rear cap is, where is it? They generally have this recessed cavity that matches the width and the height of the blade, so that you can insert an old blade into it and snap the end of it off. So if you've never seen this done, that could be part of your research of getting familiar with what this sort of knife sort of does and what it is. So yeah, there's various constraints of the various different parts. And then there's a section here that talks about how you should approach the design. So how you should use Creo and the skills that we're going to learn in Creo and that we have already learnt, and apply them to your task that you've been given. So it talks about things that we're not familiar with yet, such as skeleton modeling, but we will become familiar with that. It talks about things that we are familiar: extrudes, revolves. We haven't done blends yet. We have done a little bit of patterning, although we haven't covered 3 types yet. I think we've covered 2. We've covered rounds, we've covered chamfers, shelled features, we now know what they're about. The hold feature we've used briefly as well. So you get the idea. You will build up these sorts of skills, and this will make more sense as the weeks progress. But that's kind of a little bit of a guide as to what sort of Creo skills you're going to be expected to use in the design. Then we come in to talk about the analysis portion of the project, where you come up with an initial design. It maybe doesn't quite hit these constraints that you've been given, these non-negotiables, I suppose we could call them. So you use some of the optimization tools that we're going to cover later on in the tutorial sessions to update your design or refine it. So that would be, where are we? Somewhere there. Analysis. So we've got an analysis portion there. Then there's a portion where it's producing a tool mold, which, since we've gone to an off-site way of working, we've had to agree that this will just be a written description of the steps involved. So I think the student version of Creo doesn't include this full functionality that we would have if we were on site. So it's acceptable at this point in the report that you just describe the steps. So I will give you all the tutorial sessions so that you're aware of what the steps are, but you won't actually be able to complete them yourself. So everything that says written description of steps involved, that's what that's all about. So that applies to this section as well. So the really interesting bit, and this is the one that when you write a report or when you write an assignment, this is how I would recommend you do it largely. Have the marking criteria with you as you're generating the report itself. So as you're adding information into the report, try, at least in your own mind, to say, right, the paragraph that I've just written and the screenshots that I've just taken satisfy that section there, or the bit that I've just highlighted and commented on satisfies that section there. That is how I would structure my report, so that you can be sure that you've addressed every single one of these in your report. That would be my recommendation. Have the marking criteria to hand, either on your screen or printed out, however, and try and match up what your report looks like versus the marking scheme. That would be the most logical way of doing it, I would say, so that you can almost tick these off as you complete them. So yeah, that's the brief intro. What I expect is that people will probably go away, digest that over the next week or few weeks. You'll have questions. I don't mind sort of getting into them a little bit in the sessions. As long as we don't take up the entire session, I'm willing to sort of discuss some of the points in there a little bit. But that's the general gist. You're expected to design something similar to this, that sort of style of knife, which seems quite easy, but there's a lot of constraints that are put on your design that you have to satisfy. So that's where the difficulty comes in. And more than that, you've got to prove that you can use all these different aspects of Creo within that design process as well. When is the coursework due? That's a good question. It is in May. I am pretty sure, obviously, the date on this one is not working because the 7th of May falls on a different day. I believe it will be the 6th of May this year. I'm going to update a slightly updated version of this document that has the correct dates on it. But yeah, other than the dates on this, nothing else will change. But I believe it's the 6th of May. But leave that with me, and I will update it, and I will let you know at the next session as well. Is it a step-by-step of how we create the knife? It kind of is. As I say, my advice would be structure your report as almost an answer to these sections in the marking scheme. So what I'm looking for, I'll tell you straight off the bat, what I'm looking for when I'm marking these, and I've marked them for several years now, is I'm looking for proof that you have done the headings here, essentially. So definition of an overall skeleton model. Let's take this. Well, no, let's take this one. This is nearer to what we've done currently in the tutorials up to this point. So for 8 marks, use of extruded, revolved, blended, patterned, at least 3 different types of patterns. So it's proving that you've used these features within your parts. So how would I do that if I was approaching this task for 8 marks? So I count up the number of features and go, well, there's 1, 2, 3, 4, but there's 3 in there, so 4, 5, 6, 7, 8, 9, 10. So it's not an even split, that's the first thing. So if I could hit 8 of these in my design, I could be fairly confident on the 8 marks, but I'll try and hit every single one. So I would do a screenshot which showed a feature or a portion of my design that used the extrude feature. So I would do a screenshot maybe in the extrude feature dialog with the preview of the extrude feature in the background. I would show my model tree to show where that feature has been used. And then maybe I'd put a little bit of comment about it and say, I created the initial shape of the outside of my my knife body, the front section, using a simple extrude of da 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 da. So yeah, that would be proof that that was in there somewhere and you were able to use that tool. And then I would just run that through into all the other different types. So yeah, when is the coursework due? Is the report like a step-by-step guide? So yeah, it's a good mix of screenshots and well thought out sort of description of what you're doing at any given point. But the screenshots are kind of key because what we kind of refuse to do is accept a very poor report, but then go digging around in a student's CAD files to try and come up with proof that they've done all the tasks. So yeah, anything that you do, try and document it unequivocally in the actual document itself. I assume you'll be using Word. You don't have to, but in the Word document itself. So I hope that answers it. But yeah, I would expect you'll have many, many questions on this in the coming weeks. So I'm happy to slip questions in about this going forward. So yeah. Less wordy and more images. Yeah, to a certain extent. Don't fall into the trap of just images, but the images, certainly the screenshots, if you're smart about what you're screenshotting, they can describe quite a lot of what you've done. So yeah, I would largely agree with that comment. Less wordy, more images, but don't go too far. Yeah. So yeah, I think we'll sign off for today. Obviously, we'll come back in next week. And yeah, if you've got any more questions, bring them to the sessions and we'll try and talk a little bit more about the project. And I'll update the dates as well. Don't worry about that. So yeah, till next week, I'll see you.